Okay, back again. I've made some changes to the microphone settings, as well as some of the fonts and colors for the editors and terminals I'm using. So hopefully things are looking a little better and they're easier to read as people are following along. Um, I had picked out this bug earlier, but then I had a power outage and lost the GitHub API search page for it, but I managed to find the bug again just from memory. So this is the bug I had picked out for this attempt. This is a infinite loop happening while trying to parse different audio files. Um, and it seems like the reporter has come up with two different files, both from the WebKit test kit that surface infinite loops within this project. So I looked at the duplicate bug. I think this might be different. So we're going to treat it as different. And this bug has sample files, so at least it should be pretty easy for us to test what's going on. The project in question is called Audio Metadata Reader. And this appears to be a Dart project that reads uh, metadata from ID3 tags from MP3s and various other um, metadata formats embedded within other audio formats. So I've actually done a project way back in high school with ID3 V1 tags, and I don't remember any of it, but I do remember what they are. When you have like an MP3 file for a song, the ID3 format inside of that file will be what's used to encode like the title and the artist, um, the album name, things like that. So anything that's not really audio data. So this project is a Dart project that's meant to allow you to read a file, extract the metadata from that file, and interact with it programmatically. So I am reasonably confident on what this project is trying to do, and I think it should be pretty easy for us to uh, use the files that were linked in the bug for a reproduction case, and we'll see if we can figure out what's going on with the infinite links. This might actually be a fun bug because we might have to pull up a hex editor to see what's going on within the specific files that were posted. So, to start, let's go right ahead and try and clone this project, get it building, and if it has tests, which it does, let's try get the tests running. So, uh, first up, let's do this. Uh, Clone it, then get Zeditor running. What was it called? It was called Audio Metadata Reader. And there we go. Let's check if it has a contribution guide. It does not. So this is the first package we've run into that I think we have to kind of start entirely from scratch on that. It is a Dart project, and Dart is actually a language that I use quite a bit in my day job. So uh, let's see if we can get Dart up and running. So Dart is installed. Pub is deprecated anymore. I deprecated now. Uh, let's just run Dart test and see if it runs the tests. It does. All the tests pass right now, so that's a good sign. Let's have a look at the test directory. Um, this might be the easiest way to uh, get these sample MP3s running. Now, I don't know whether it's fair game for us to copy the files from the WebKit directory here. Um, it might not. But regardless, let's at least use the test as a runner for seeing if we can reproduce the issue. So go into the test directory, into mp3, we should be able to just download the mp3 file from the WebKit project into this directory. Yep, not a problem. And back to Zeditor, let's go to test mp3, the Dart file, and all the other tests here seem pretty trivial. So let's just write another test, which is check. I don't even know if it's malformed, but check file from WebKit. The reporter of the bug commented that maybe WebKit chose interesting audio files, so maybe the files from the WebKit test suite are meant to be malformed or something like that, but I don't really know, and we probably won't know until we pull out like a text editor, hex editor or something like that. But the file that we're adding is mp3 with ID3. Let's read the metadata and just do an expectation on the title. So if we can reproduce the bug, we would expect this test not to complete at all and just kind of hang attempting to read metadata from this file. Oh, wrong. Let's go back and probe test. Dart test. No parser found for a .mp3 file. .test/mp3. That seems odd. Oh, it just came back as a HTML file. It didn't come back as the mp3 file. So this might actually just be a browser. Yeah, it is. It's not the file itself. So if we get the raw URL and try this again, now if we check this, now it just shows empty, but let's discard. Yeah, so now it's not text data, so Dart test. So yeah, given just the 10 seconds already, there's a fairly good chance that this is hitting an infinite loop. So let's just break. We'll go back to the bug. And interestingly enough, this the reporter of the bug found where this infinite loop is happening again. Now, I'm not going to trust that, so libsource utils buffer.dart is reading something of a certain size and waiting until everything is filled. And never completing. So let's just do a quick print here. And do this. Filled 595, size 1500. Sure enough, just infinitely looping, never changing. Now, I don't know if I can actually break this anymore. Oh, eventually. Okay. Got to be careful about printing in a tight loop, apparently. So, this is the number of bytes that we are trying, that have left to be copied. If toCopy is greater than buffered bytes, toCopy is equal to buffered bytes. And chances are buffered bytes is going to be 0 here. Result.setRange filled plus 2 copy from underscore buffer 0, filled plus equals 2 copy. So we're copying a chunk of bytes with size 2 copy from buffered bytes to filled, no, to result. The cursor equals 2 copy. Fill the buffer again. If more data is needed, if filled is less than size, then we call fill. So it seems likely here that this is just going to give us 0. Yep. Okay. Now, if that's giving us 0, that means this code is expecting underscore fill to increase buffered bytes, and it isn't. So let's look at underscore fill. Buffered bytes equals random access file read into sync buffer. And this probably won't advance if we're already at the end of the file, is going to be my guess. So let's look at the random access file implementation for Dart. It was read, right? Read into sync. Synchronously reads into an existing buffer. It reads bytes, writes them into the range. The start must be non-negative and no greater than the buffer length. If end is omitted, defaults to buffer.length. Otherwise, end must be no less than start and no greater than buffer.length. Returns the number of bytes read. This may be less than end minus start if the file doesn't have that many bytes to read. Throws a file system exception if the operation fails. So this is going to be the key part. We expect to read a certain number of bytes, but we're at the end of the file. We have no more bytes to read, and the indicator for that when you call this is just going to be read into sync, probably returning 0, yes. And that's not what we're expecting here. So, or sorry, in the case that it returns 0, this code, this read code, just keeps looping and never actually advances forward. And probably more specifically, it doesn't have an error case that it doesn't have an error case that handles read into sync returning 0, and therefore it doesn't have an error case for when read into sync only reads 0 bytes and therefore ends up tight looping. So read it directly from file, makes the read faster, no need to use the buffer. If size is greater than buffer size, read into sync, result remaining, fill, result remaining. So everywhere that we're calling read into sync in this, we're expecting the result to be more than 0. Let's see if that's true. Well, there's only 2 places. So buffer. No, so we call fill at the end. So yeah, so there's cases where we like eagerly fill the buffer, and that isn't a case where I was wondering whether if read into sync returned 0, could we just throw an exception here, like an end of file exception? But it looks like that isn't possible because there's times where we're eagerly filling the buffer, like here or here. So we can't do that. I'm going to check whether Dart has a end of file exception or something similar. Doesn't look like it. Then I'm going to check if this project uses custom exceptions. It uses this thing called metadata parser exception. Perfect. No parser for metadata. Throw no metadata, throw metadata parser exception. The only place we do it is in MP4. So let's look for mp4.dart, throw. A read box. Yes, okay. So inside of the parse call, which I believe is where we're going to be for the MP3 case of ID3 v1 or ID3 v2, it's fair game for us to throw a metadata parser exception. Track, message. Yeah. So in buffer, we need to the easiest thing would be to throw on 0 bytes. So while we're looping, where else do we call fill? Once there, once there, once there, refill. Set position sync, fill, skip. Yeah, so in this case, we don't immediately use the results of the buffer. So that's fine. In this case, we are immediately using the results of the buffer, but this is the first iteration of the loop. So it's not that much of a problem if filled becomes 0. This is the case that we care about where we're inside of this loop. Here we are advancing the file to a arbitrary position and just kind of filling the buffer as a hint. This isn't, we're not immediately using that data. And similarly here, we're advancing to a specific position and then calling fill just to kind of fill the buffer eagerly, and we're not immediately using that data. So the only case that we actually care about in terms of the tight loop is here. And so throw on no data. Now let's, the MP4 file again is probably importing the audio metadata reader. Yeah. Utils. Bit manipulator. Okay. Let's see if we can. I don't know if we'll be allowed, but this might throw on like a circular import or something. Throw on no data. So if buffered bytes is equal to 0, throw metadata parser exception and track. I don't know. Let's see if does random access file. Does this extend file? It doesn't look like it. So the other case that in the MP4 file, when we were throwing metadata, they just passed this, but this is the only case where this thing is set, isn't it? No, we also throw it in the parser. Okay, but apparently this is their way of omitting the file, so we can do this. Expected more data in file. And if we do this, and like I said, the only one that we care about is this one, then now if this tight loop hits, if we get to here, we try to fill the buffer, but the buffer ends up with 0 bytes. We're going to hit the 0 check in this new function that we've added and throw this exception. So tab width, spaces, indent. Huh, it figures it out. Nope. Okay. So maybe if we install the Dart exception. Oh, there we go. We get syntax highlighting. That's kind of nice. Is it gonna? Oh, now it figures this out. Okay. Throws a metadata parser exception after if a previous call to fill was unable to read any data from the file. If we attempt to read once it reaches the end of the file is reached, subsequent reads from random access file will read 0 bytes without failing. This can cause read below to infinite loop. Instead we terminate. Sure, let's just leave it there. So now if we run Dart test, the test should fail, but at least it doesn't infinite loop, and we see the expected more data in file warning, or sorry, error. So now in the MP3 parser test, I'm going to do a check of the WebKit license. I don't see a license file. Does it have it on here? Does not. So let's just yeah, I'm trying to determine whether we should just copy this file into their repository and use it as the test case, or not. The other thing is that like this fixes the infinite loop, but I'm also not sure if this file should have metadata. The infinite loop's definitely an issue. Now, one way we could do that is check it against something built into my system. So MP3 with ID3, properties, audio video properties. GStreamer is missing a plugin. That's unfortunate. So is there another such project? There's lots. This is very common. Let's see if my distro has, it has KID3, KDQT, CLI. See if we go back. Test MP3. So downloaded a utility that can read these tags from my distro package manager. We can just pass in the path, it looks like. Help. Can I get tag frame? Just call get file encoder settings ID3 v2.4.0. Select save pwd. Okay. Is there a way to read the length? Okay. At least this seemed to have read the tags correctly. At least this encoder settings tag. So I'm a little hesitant to submit this infinite loop fix as is, because even though the fix is probably a good one, we might be able to do better by actually figuring out why we can't produce these values. So what I'm going to do next is go back here, and actually we should have had the test result. Where did I put that? I think it's test. The test result has a stack trace. So we can see that this is happening in ID3v2 line 250. So let's see what's going on there. Usually the Xing header is located after about 30 bytes. Then the header size is about 150 bytes. Buffer.read, and buffer is okay. Yeah, so this is a really good call to actually go up the trace and look a little deeper, because this straight up looks like it will be broken for tags that are less than 1500 bytes. So we have this .read 1500, but if there's less than 1500 bytes left in the file, this will infinite loop. And we don't even know if this is what we're looking for. So can we get the position here? And closure. This is a, once again, Dart random access file position. It is, position sync. This project is using synchronous I/O. Okay, so in the case of check file from WebKit, the position before the read is 644. But if we go, I'm guessing that if we go to test MP3 and we look at the size of MP3 with ID3, it's a very small file, 644 bytes. So we are already at the end of the file and trying to read 1500 more bytes, which is just not going to work. So that's not good. I'm going to actually give this file a listen and see whether, like, 644 bytes is really small. I'm going to see whether it actually contains any actual audio data. I don't hear anything. Okay. What do we want to do from here? This is indeed a strange file, but there's definitely a an issue here. So buffer set position size close down. Okay, let's read through this code and see if we can understand what's going on. So we go to the first byte in the file, we create the buffer that we're using for reading, we read 10 bytes. So already here, if you tried to read a file less than 10 bytes, this will infinite loop. The major version, the header bytes 3. Major version 3, 1, metadata. Okay, so it doesn't even try. Seven, 14, 21, size bytes, sublist 6. That's going to give us 4 bytes because we originally read 10. ID3 tag minus the ID3 header size. The offset is 10. The external header contains information. Parsing the tag information. header bytes. 5, 6 is equal to 1. Extended header size, get uint32, buffer.read4, buffer.skip, extended header size, -4. So this is attempting to advance forward by bytes that are encoded after the first 10 bytes if a specific bit on one of the header bytes is set, while offset is less than size. Okay. Size is this. Frame equals get frame reader major version if frame equals null. Break offset equals offset plus 10 plus frame dot size. Offset equals offset plus 10 plus frame dot size. So does that mean that this is reading 10 bytes and then reading bytes and then it reads ID size flags, process frame, frame dot size, get frame. This is does this include the offset? Is that what? What does process frame do? Frame ID. Yeah, okay, so all of this reads. So at any point if it cuts short, it's going to infinite loop. So all of this is working though. The interesting thing is that after we read through all these frames, which I'm guessing are all valid frames, then we have looped through size, and size is the number of bytes that were in the original size of the ID3 tag. So this afterwards seems odd because we've just read through all the data in the ID3 tag and then we jump past, well, it's going to be size plus 10, which is the original header byte. So we jump past the ID3 tag and then we look for, oh, okay, this is the start of the MP3 data, and there's some stuff that we want from the MP3 data. MP3 frame header 0 first. They have performance issues. First isn't. Okay. So we're reading a header. Then we get version, we get MPEG layer from the frame header. We do a sample rate from the version, and this Xing header is located after about 30 bytes. Then the header size is about 150 bytes. Yeah, so did update file size without metadata minus size. Okay. So this is for computing the variable bit rate, duration, seconds, over metadata.bitrate. Oh, we're reading the duration of the file and we're computing it. And there's a special header that will tell us the duration from this. But we can't safely read 1500 bytes. So what we can do is we can safely read the number of bytes left in the file. This is also not safe because if all the bytes are 0, then this is going to throw an out of bounds exception because I is just going to keep increasing. So, remaining bytes equals buffer dot read remaining. Let's actually do read at most in count size. Reads at most size bytes from the file, safely handling may return a list, may return a smaller list if random access file has fewer than size bytes remaining. Final remaining size equals random access file dot length sync minus random access file dot position sync return read size equals max of remaining size and size min, not max, and return read size. So now, this is almost right, and I almost had a bug in this if I hadn't thought about it again. When you call this, we might actually have already read data into the buffer because of all the places that this file is eagerly reading into the buffer. So what we can do is do something like, and this will be underscore buffered bytes minus underscore cursor. So that's the number of bytes left in the buffer plus random access file dot size length sync minus random access dot position sync. The number of bytes remaining to be read from the file. Read at most So most functions may return if remaining bytes is less than size. Final read size equals min of size and remaining bytes, and then return read of read size. And so this implementation now should safely handle value of livable read size. Oh, size. That's not right. Read size. So now instead of calling read 1500 and then entering an infinite loop, if the file has less than 1500 bytes left, now we can call this read at most function, which will return all the remaining bytes in the file, but will return at most size bytes. But if there's fewer than that many bytes left in the file, we'll just return all the bytes that are left in the file. And still we're using the read utility because it handles copying from buffered bytes if we need to. So in ID3v2 now, instead of calling buffer.read, we're going to call buffer.read at most. Don't assume that the file. It's pretty obvious what's going on. I don't think that needs a comment. So here we want to do while I is less than possible xing header.length and possible xing header. Then we increase I, and then if I is less than possible xing header.length minus 4. And so the idea here is that, is it 4? Is 4 right or is it 3? 3. So we advance through the possible xing header list while we haven't reached the end of the list and while the byte that we're at is 0. This part is the same as the old logic. And then once we find a byte that isn't 0, or I reaches the end of the list, then we check whether we have 4 bytes remaining in the list. And then only once we know that there's 4 bytes remaining in the list, then we check the first, second, third, and fourth byte that we're expecting. Now, even in this case, this is not sublist. I plus 8 to I plus 12. So we need at least 12 bytes, not Yeah, we need at least 12 bytes. So 11. And that should make sure that we have enough data bytes available to read all of this. So before, for example, if we found the non-zero byte at byte 1496, then this would have succeeded, this would have succeeded, this would have succeeded, this could have succeeded. But then when you try to do the I plus 7, you're now indexing 1503 into this buffer, and the buffer only has length 1500, and this would have thrown an exception. So the code here is definitely not being particularly careful about array indexes past the end of the list. This is not the cleanest, but it at least means that this 11 means that we have at least 12 bytes left in the buffer, which means this sublist call won't fail. And I think that's about as good as I can hope for. Fixing all of the read calls throughout is going to be a big challenge, because any of these read calls could infinite loop if the file isn't long enough, and you can't always assume that your files are well formed. So I'm going to run the test again and see what this does now. Okay, so we actually do get a value for the title. Wait, no. It's null. So what did I get in... it was kid3 CLI mp3 with id3 get. We got encoder settings. So if I look here, does this library support reading encoder settings? Track, title, pictures, sample rate, lyrics. Bitrate, artist, album. Let's see what... Let's see what this does. Actual value of 0. So I'm trying to see if I can get any data out of this file. 56,000. Okay, so I can at least get the bit rate. Okay. I'm now wondering what I should do with the file for the test, whether I should include it in the commit or whether I should just exclude it, because the problem is I don't really know what this is licensed under. Yeah. Here. LGPL and similar. So I don't really think that I can send out a commit incorporating WebKit resources into this project. So I'm probably just going to remove the test, and it's unfortunate, but I'm not going to try and reconstruct an MP3 by hand that services this issue. This is probably a pretty unique MP3 file. So I'm going to delete this and delete the new test that I added. Don't like doing this, but there's not... The test coverage here isn't great already, and this is not the only such issue. Maybe what I could do, actually, here's an idea. If I wanted to do this, I could potentially take the file that this author is already using in their repository and create a truncated version that everything's the same right up until that header. So let's give that a shot. That actually might be kind of fun. So what is it? XXD? Is that the Hexel? Hex edit? Let's give it a shot. And let's do, if I look at track, yeah, we're getting some data from here. So let's and the value that I'm looking for in ID3v2, where we do read at most, is 5869. So 5868. Let's go back up. 5869. Ooh. It might not be in this file. Oh, never mind. This is decimal, not... No, these are hex. So it's going to be after the size of the ID3 header, and the ID3 header bytes are located in the 0, 7th, 8th, 9th, and 10th bytes. So let's go here. Fourth, 5th, 6th, 7th, 8th, 9th, 10th. So D21. 0 D21 plus 10. But I don't see zeros here. Check one more time. We're going to size plus 10. So D21 plus 10 is going to be D3, no, 2B, 98, D2, A0. Yeah, I don't see that header that it's looking for in this file. So let's try the other one and see if it has it. Caress your soul. Length this time is 1 to F. And we're supposed to go forward 10 bytes. And we're looking for 58. 58 is just not found. That seems 58. Uh, 5869. 5869 6E67. Yeah, okay. So this file has whatever header it is that we're trying to read, this Xing header. So let's do a copy of this and do truncated. Destination file. Oh. Hex edit, truncate. Escape plus T. Uh, 5859 6E 67. So can I do this? Edit, save, and exit. Control C. And now we have a 205 byte Caress Your Soul file. So if we go back to the MP3 parser test and we undo this and we do parses from truncated MP3 file, the Caress Your Soul truncated cleaned.mp3 file is truncated immediately before the Xing header. We should still be able to read the you know what, this is probably going to surface a different error, but we'll keep going for now. To read the ID3 tag data. Same stuff. And now we do Dart test, and I'm guessing this is going to fail. Yeah, the duration, that's not surprising that we can't read that because... Oh, it works. Okay. Yeah, so the duration header, that's part of... what was it just... It wasn't throwing an exception, it was just... Yeah, it just didn't get a duration value, which is totally fine. Okay, so if we omit that, all the other data reads. Now let's go back here, and I'm not going to revert all my changes, but I'm just going to do this equals read 1500. If I do this, I'm guessing now I get the more data in file. So that is unrelated to a fix now. Like, this is the actual fix for the file that we're looking at. But both fixes are probably good. I might structure the commits so that we can send them both out. But regardless, we have a fix, at least for the first file. So, test, yes, okay. And then buffer, read at most. All of this looks pretty decent. We have the test, we explain the file, we've got the truncated file, we can commit that. We're verifying the same data except for the duration value. All of that is pretty reasonable. What changes have we made? We made the change to ID3v2 to use read at most when reading the Xing header. We made the buffer change so that this throws an exception instead of infinite looping, which I think is a good overall change. It's a little unrelated now, but it's still probably good. That one place might still deserve a comment. That's buffer throw on. We are type looping until we've read all the requested bytes. However, if there are no bytes left to read in the file, this will loop infinitely. Instead, we can throw if we don't read. Can probably be shorter. Avoid infinite loops if we are trying to read more data than there is left in the file. Honestly, this might actually be we've made some changes now that I think we can actually do this better. I think there's no reason for us not to just do if size is greater than remaining bytes. Well, the question here is whether there's a performance implication for us calling length sync and position sync multiple times. Probably not, but this is a little bit safer. I don't know whether these are gonna call like stat calls to the OS. This should be fast, but length is a little harder to predict. Yeah, we might throw a file system exception. So let's stick with it as is. I think we're pretty good. I think that's we have a test case. It's passing. We have fixed part of the issue. I'm going to write up a reasonable CL commit message for this because, like I said, every other call in this file has the potential to infinite loop, every other read call. This is not really a feasible pattern if you're reading arbitrary input. Like if you trust your input, maybe, but generally you shouldn't trust your input. So even just right here, the very first thing in parse, if file is less than 10 bytes, you get an infinite loop. I've fixed that by throwing an exception, which I think is reasonable, but there might be other cases where it should get handled better than that. Regardless, I think this is good enough to send out for a change, and we'll see what the author says. I don't know if there's other formatting changes. I don't think so. Buffer. No, I think we're pretty good. Address infinite loops while reading ID 3v2 tags. Buffer read call will infinitely loop if there is number of bytes remaining in the file is than the requested size. A large number of read calls in ID3 v2 parser are risk of infinitely looping on malformed files instead of what's the right phrasing? I'm changing this to throw an exception, which is likely more useful than I'm changing buffer to throw exception to text are no more bytes to read from the file. There is a single more egregious. That's the right spelling, right? Nope. Egregious case. With the potential. I don't even know if this is the right Xing header. Sure. Xing header. The parser blindly reads 1500 bytes to search for the header, but there is no even file 1500 bytes meaning to read. Most utility method to buffer, which will in all cases there are fewer than size bytes remaining. Hitting some of the start Xing to ensure are sure. I think that's pretty decent. I forgot to fork. Fork. Create. And git log. Got that. Let's do v93v2. Oops. And we have a new pull request. And this copied the CL description. Let's check one more time. I is less than button than 8. We need this 11. We talked about the logic for that. Remaining bytes is a useful utility. Throw read it most and the extra test. This looks good to me. Yeah. See what the author says. Oh, I forgot to link the original issue. this is a partial fix. This is a partial fix for number 47. I haven't only looked at the first case. The second HG case is likely unrelated. Might be unrelated. Chances are it still has to do with the read calls. Let's check. 82 parse unique. Yeah. So exact same thing. This is forcing a read of 27 bytes, and if the file doesn't have 27 bytes, or even if the buffer, because buffer.skip is probably doing the same thing. No, it's just advancing the position. It's not reading all the bytes, but chances are this buffer.read call is doing the same thing, that it's hanging. So that might be worth looking at in the future. But this is at least one case. And I think we're good to go. Alrighty, so not the longest of videos, but longer than the last one. Not the hardest bug to fix, but this one I think was made a little harder by kind of the state of the project. The project definitely isn't handling this type of error already, so there wasn't really a pattern to follow, and I kind of had to invent everything as I went. I don't think it's the most beautiful code, but I think it's an improvement over the current state of the project, so I don't really have too much of a issue sending it out, and hopefully the contribution is appreciated. In the meantime, thanks everyone for watching, and see you next time.